Remember that Y2K thing a few years ago? Where everyone was afraid the world was going to end because computer programmers saved space by putting dates as 77 for 1977, 85 for 1985, or 90 for 1990. But then it became clear that when the year 2000 finally rolled around, all of the computers would think it was actually 00, or the year 1900. Well, it turns out Hubble has something similar. Only Hubble's clock restarts every 6,213 days, 18 hours, 48 minutes, and 31.875 seconds. Or roughly every 17 years for those of you who like counting. That's because Hubble's computers have a different way of tracking time than we have here on the ground. You'd think it would be as simple as syncing our ground clocks with Hubble's personal timepiece, but you'd be surprised. Hubble's onboard clock is a 32-bit elapsed time counter. So instead of Hubble counting up seconds, days, months, and years like a calendar as we know it, Hubble counts every 125 milliseconds, or 1/8 of a second for those of you who like counting. Using 32 bits, up to 4,294,967,295 increments can be stored. Once that final bit is hit, however, everything restarts again from the top. So to clarify, when Hubble was first deployed on April 24, 1990, its clock began counting up every 1/8 of a second from April 24, 1990. And for every one of those 1/8 of a second, Hubble's binary counter got one step closer to its maximum of 4,294,967,295 before restarting back to 0. This actually happened already. Hubble had its first clock rollover back on April 29, 2007. So from 1990 to 2007 is 17 years, and then from 2007 to 2024 is another 17 years. So this will be Hubble's second clock rollover. When you do the math, 4,294,967,295 multiplied by 0.125, or 1/8 of a second, divided by 60 seconds, divided by 60 minutes, divided by 24 hours equals 6,213.78 days. Our magic number of around 17 years. That's all because Hubble's initial requirements back when it was being designed and built in the 1970s and 80s specified a base mission period of 10 years with a 15-year operational goal. Therefore, the 32-bit clock design with rollovers every 17 years met those requirements. But why does this even matter? Why not just let the numbers roll over on their own every 17 years and start things from the top again? Well, if we tried that, things would get pretty weird. That's because Hubble would suddenly think it was 17 years younger. It would think it was back at that first clock rollover we just talked about that happened on April 29, 2007. If Hubble thought it was 17 years ago, it would be very confusing. Hubble's antennas would point in the wrong direction when trying to send data or receive commands from a communications satellite that was somewhere else. Because Hubble would think everything in space was in the same place it was 17 years prior, Hubble would even think it was in a different place. And even more dangerous, Hubble would think that the sun was in a different place. And if Hubble looks at the sun, that could be very, very bad for its delicate instruments. The fact that the second clock rollover 34 years after Hubble's initial deployment is now upon us is yet another testament to the dedication and ingenuity of everyone who built, upgraded, and continues to maintain Hubble as the premier astronomical observatory we have come to know and love. Back before the new millennium, computer engineers around the world updated things to have all 4 numbers of the year instead of just the last 2. So we managed to keep that Y2K bug from actually destroying everything. And just like we managed to avoid any mishaps with that issue, our team of Hubble engineers on the ground have sent up new routines to ensure that our trusty space telescope could successfully roll over its clock without dropping back 17 years. That way Hubble can keep doing its amazing work until the next clock rollover in 2041.